gentlemen, my name is Amira Christina and I'm from UMP Pahang. As one of the inventors of this project, I would like to present our innovation regarding the enhancement of laser absorptivity in metal by laser surface modification. Let's start with the introduction of this project. This innovation is currently in 4th TRL and aims to improve the interaction between laser and material by increasing the absorptivity of metal through surface roughness by using laser surface modification. That's quite long to begin with. So, let me explain about the laser technology. For simplification, laser, which has been found since 1960s, has been involved and implemented into different type of application such as laser brazing, laser welding, and laser cutting in various industries. For instance, biomedical, manufacturing, and automotive industry. Generally, when laser radiates a surface layer, the energy can either be reflected toward the ambient or absorbed into the material. It is worth noting that the absorbed energy is the one contribute to the laser material processing, while the reflected energy will be wasted into the atmosphere. Hence, the real concern is the energy absorbed into the metal is very low. This can be supported by the findings that has been summarized through this bar graph. Eventually, the low absorptivity will lead into the low energy efficiency. This is because more energy from the supply is wasted and only a part of them will be absorbed into the metal. Hence, many industries often invest big capital to cover the issue of low energy efficiency. They invested huge amount of capital just for the sake of high power laser machine. And please bear in mind, big industries such as automotive needs hundreds or even thousands of high power laser machine for their assembly line. So, how can we increase the energy absorptivity as well as reduce the capital cost for industry? After evaluating all the possible solutions, we, the researcher in JWL lab, came up with a practical solution to tackle this issue. A few moments ago, I have shown the basic interaction between laser and material. I hope all of you still remember this schematic diagram. So, in order to increase the energy absorption into the metal, we have to increase the surface roughness. This is because a rough surface can scatter the energy over a larger surface area and multiplying the absorption into the metal. Therefore, the solution for our previous problem has been discovered. The next issue would be how can we increase the roughness of the surface. As we are currently in IR 4.0 phase, we have to prepare ourselves for the advanced technology. Ergo, the researcher in JWL lab located in UMP Pahang proposed an idea which in line with the IR. Our suggestion to increase the energy absorptivity through surface roughness is laser surface modification. There are several reasons why we suggest this approach, and this approach will surely in favor of industry. The one that we want to highlight is LSM is a fast process. Well, ladies and gentlemen, as well as we aware, time is money for industry. In fact, for all of us, and that's why we suggested a fast process for industry to increase the roughness of the surface. Apart from that, LSM also able to produce a uniform finishing. Compared to the conventional approach, for instance sandblasting, which has irregular finishing, LSM has a lot to offer in terms of finishing. And last but not least, LSM possesses a high accuracy and precision since we can control the depth or other dimension of the roughness by adjusting the laser parameter. Accordingly, these elements are vital to industry in order for them to save money, time, or even reduce the manpower. Next, I will proceed to the key point of this presentation, where I will describe the process flow and the validation with illustrated schematic diagram. Let's say we have a sample, a simple metal in form of cylinder. For conventional process, which currently apply in industry, this sample will be heated by using a high power laser. Please be noted that laser heating was chosen for validation because it is the most basic form of laser material processing. In other words, laser heating is the fundamental of laser brazing, laser welding, or even laser cutting. As for our innovation, we propose a method enhanced by laser modified, which known as LSM process. Afterwards, in order to produce the similar outcome as conventional, the modified sample will undergo laser heating process, but with extra benefit. For instance, the sample is heated with same high laser power with less duration, or the sample is heated with much lower laser power but heated with the same period. Either methods could produce the same outcome as conventional approach. Once again, I will demonstrate with strong justification to convince all of you. The video shows how we conducted the LSM process in our lab. Modified sample and the non-modified sample will undergo surface characterization process. Following will be heated by using laser with same parameter for both samples. The other video shows how we conducted the laser heating process. The graph shows the result of heating temperature for both non-modified and modified sample. We can see clearly there is significant increase for modified sample noted as the red line in terms of maximum temperature compared to the non-modified surface. Apart from that, the modified sample also took shorter time to boost up the temperature compared to the non-modified sample. This result reflects that the modified sample by LSM can improve energy absorptivity in terms of temperature rise. Subsequently, our innovation will surely have huge impact for different types of sectors. For instance, the environment. When industry apply low laser power for their laser material processing, there will be less energy usage, which can lead to high energy efficiency. Moreover, industry doesn't need to spend a fortune to invest for high laser power machine. Machine with low power is sufficient. Even though they have bought laser machine with high power, they could continue operating the machine but applying much lower laser power. Eventually, it will lead to the reduction of product price since the cost of production is reduced. After taking everything into consideration, our innovation will also affect our social economy. This is because when the capital is reduced, it will encourage more SME corporation to start implementing the laser technology, which will then promote to advance society. It seems like I talk a lot about the innovation and hopefully it could convince all of you. If that's not enough, please be patient. We've got few tricks up our sleeve. These are the list of publications and conferences related to the innovation. There is one article that has been published and 2 articles accepted for journal publications. Apart from that, this innovation has been presented at international and domestic conferences. And last but not least, this project has been supported and involved in such collaboration with Tokai University and Tokyo-based corporation from Japan. We would like to express our sincere thanks to JWL Lab and Materials Lab of Universiti Malaysia Pahang for providing the equipments and the facilities for this project. That's all from me. Thank you for watching. Have a good day and stay safe. Bye.